And now I'm going for 3. So 3 is 3q over the square root of 2d over 2 cubed. And now I'm going to have 0, the square root of 2, d over 2, and 0. And last but not least, see if I can fit it, I have k 4q over the square root of 2d over 2, all cubed again. And I have the square root of 2, d over 2, 0, 0. Looks like I got it. Okay, so now I can pull kq and in the denominator out of each of them. So I have EP is equal to kq over the square root of 2, d over 2, all cubed. That's common in each one of these terms. And so what I'm going to do is I'm going to put each of the vector terms together. So in my x, I have 0 here, so I'll put a 0. Here I have 2 times the square root of 2, d over 2, and that's a negative, so I'm going to have negative 2 times the square root of 2 times d all over 2. That's for this term, and now here I've got another 0 plus 0, and here I have plus 4 square root of 2 d over 2. Alright, so there's my x. Those are my x terms. My y terms, I'm going to have just a negative square root of 2 d over 2. I'm going to have 0 for this term, plus 0. I'm going to have a positive 3 plus 3 times the square root of 2 d over 2, plus the last one is 0. And then I have just 0 for the z term. Okay, so now if I look here, I have this becomes, these cancel, so I just have the square root of 2d, and this becomes 2, and this becomes 1. Now if I look here, so let's see, EP is equal to kq, and let's simplify this now too. If I take the cube root of, if I take the square root of 2 cubed, that means square root of 2 times square root of 2 times square root of 2, so that gives me 2 times the square root of 2, d cubed, and now over 2 cubed, which is over 8. Okay, and so I can cancel here, and I get over 4, and I'm going to go through this vector, so I have 0, and now I have minus square root of 2d plus 2 times the square root of 2d, which gives me just, so it would be like one of these, and a negative one of these, and a positive 2 of these, so that just gives me one of them. That says square root of 2 times d. And now here I have 3 halves of this square root of 2d, and I have minus 1 half, so that gives me 2 halves, so I have 2 over 2, which is 1, so that I just have here is 2 square root of 2d, and then this is 0. If you got confused there, work that out. So what I did was I just said the square root of 2 times d is my common thing in each, and I factored. So I factored a minus 1 out of here, and I factored a positive 2, so it's 2 minus 1. Here I factored the square root of 2, square root of 2 times d, and so I have a negative, I have minus a half plus 3 halves, which is 1. So negative 1 half plus 3 halves is 2 halves, which is 1. Okay, so now, let's see, I can bring my 4 up to the top, so 4kq over the square root of 2 times d cubed. And here I have, in both of these terms, I have the square root of 2 times d. And so I'm left with 1, 1, 0. So my square root of 2's cancel. And I have a d here, so a d there. So I have EP is equal to 4kq over d squared. And now 1, 1, 0. Now I have to find the magnitude. So, so the magnitude, let's do this here, the magnitude of EP is equal to, I need to take x squared, the EP x squared plus the EPY squared. So this is in there too, so I'll just take that out. 4kq over d squared, and now I'm going to say the square root of 1 squared plus 1 squared, and that is 4kq over d squared, and this would be times the square root of 2. So that would be the magnitude, and then my direction, so if I want to know theta, tangent let's see, tangent inverse of theta is equal to, let's see, I should do this. Cross that out. Theta is equal to tangent inverse of the y term over the x term. So I've got, it should be EPY over EPX equals, now notice that that EPY has this term in it right here, and EPX, both of them have this term in it, so they're going to cancel. So I'm just left with tangent inverse of 1 over 1, and so I know theta is going to equal 45 degrees. Okay, so let's see if, so what we found then is we have our vector for E. We have the magnitude of it here, 4kq over d squared times the square root of d. We know the direction, right? If we have a vector that's in the 1, 1 direction, we know it's at 45 degrees, and we find it here mathematically, 45 degrees. But let's go back for a second and think about this problem.